Hello, this is Dr. Grande. Welcome to my video on running the Shapiro-Wilk test in SPSS. The Shapiro-Wilk test is a test of normality and is commonly used for testing the normality assumption in parametric statistics. So I have here a data set that has 4 variables, an ID number, an independent variable with 2 levels, control and CBT, and then some pre-test and post-test scores. And I want to run a Shapiro-Wilk test to test the normality of the pre-test and post-test variables. So first we'll go to Analyze, then Descriptive Statistics, then Explore. And this is the dialog that comes up. Pre-test over to the dependent list, and post-test over to the dependent list. Under Options, I'm going to leave them the same, exclude cases listwise. Plots, I'm going to uncheck stem and leaf, but then check histogram. And I'm going to check off normality plots with tests. Click Continue. And then for statistics, I'm just going to add outliers to the default items. Click Continue. And from this point, we can click OK and run the test. And you can see there's a variety of information that's provided. You have a case processing summary. You can see there's 90 scores for the pre-test and 90 for the post-test and none missing. You have your descriptives for pre-test and post-test, including the mean, the lower and upper bounds for the confidence interval, the median, standard deviation, and so on. And then we have extreme values. So you have in the pretest by case number, and it gives you the value as well, the high values, and then in the pretest the low values, and the same thing for the post-test. Be mindful of the notation. You can see it in this last value of 49 for the highest in pretest, and similarly the 30 for lowest, and again the last value for the post-test and pretest. There's a description of what that means down here, and you can see, for example, for the 49, this is providing only a partial list of cases with the value of 49. So this table is helpful for spotting outliers. And then we actually move to the test of normality, the Shapiro-Wilk. And you can see for the pre-test, the significance is 0.022, and the post-test is 0.182. So the way to understand the significance value is to consider that the Shapiro-Wilk test tests whether the pre-test value, in this case, and the post-test are statistically significantly different from a normal distribution. So the null hypothesis in this case, say looking at the pretest, is that the pretest scores are not statistically significantly different from the normal distribution. So if we have a value of 0.022 and we set the alpha at 0.05, which is a common alpha value for testing normality, we see that 0.022 is less than 0.05. Therefore, we would reject the null hypothesis, and we would presume there is a statistically significant difference between the pretest and the normal distribution, and therefore presume that the pretest scores are not normally distributed. So in this case, we reject the null hypothesis and presume the pretest values are not normally distributed. So taking a look at the post-test, for Shapiro-Wilk, it's 0.182, which is greater than 0.05, which means we would fail to reject the null hypothesis or accept the null hypothesis. And remember, the null hypothesis states that there is no statistically significant difference between the post-test and the normal distribution. So we would presume that the post-test is normally distributed. It's worth noting here under test of normality that we have the Shapiro-Wilk, but we also have the KS test that's run at the same time. And in this instance, looking at the significance values, even though they are different from the KS test to the Shapiro-Wilk, we would draw the same conclusion, that the pretest is not normally distributed and the post-test is normally distributed. But sometimes that's not the case. Sometimes the KS test indicates one thing and the Shapiro-Wilk another. Generally speaking, the Shapiro-Wilk is considered a better test to use for testing normality. So then I'll take a look at the histograms. You can see this is the histogram for the pretest, and it doesn't really look normally distributed. Clearly we're going to use the test, the significance level, to determine that, but it's a good idea just to look at the histogram, and you can see that it doesn't really appear normally distributed. Now remember, we are presuming the post-test is based on the Shapiro-Wilk value, so if I move down to the histogram for the post-test, you can see this does look more or less normally distributed. This histogram is distinctly different than the histogram we saw for the pretest. I hope this video on running the Shapiro-Wilk test was helpful to you. As always, if you have any questions or concerns, feel free to contact me, and I'll be happy to assist you.